Okay, in this video we're going to talk about Unit 5, Objective 3, which is going to be describing asymptotes with limits. So we're going to focus on the function f of x equals x over x minus 1. Now, you probably could figure out what this looks like, but it might be a waste of time once we know how to find our asymptotes with limits. But if you wanted to know what this looked like, our function would look like this. Right there. So there, if you look, we have two different types of asymptotes on this problem. We have a vertical asymptote at x equals 1. So my function's not going to cross that one. And we have a horizontal asymptote at y equals 1. So we're going to talk about both types of asymptotes and how we use limits to find them. We're going to start with the vertical asymptotes because that's one that AP doesn't really focus on too much, so we're going to get that out of the way, and then we're going to talk about the horizontal asymptotes. So when they're asking about a vertical asymptote, they're really going to ask you this limit problem here. So the limit as x approaches 1 of x over x minus 1. So our first thought process is, alright, I see a limit problem. I want to plug in the value that I'm approaching in for x. If we do that, we're going to get 1 over 0, which we know is going to be undefined. And this is supported by looking at the graph. You can see that as you come in from the left-hand side, your graph is going to be going down to negative infinity. As you come in from the right-hand side, your graph's going up to positive infinity. You're not actually going to a y value. So our limit is going to be undefined. Now, how we are going to know that we have a vertical asymptote there without looking at the graph is we're going to inspect the limit from the left-hand side and from the right-hand side. So if we think about the limit from the left-hand side, that means we want to take numbers that are getting very, very, very close to 1, but just to the left of it. So if we were to pick 0.999, that is very, very close to x on the left-hand side of x. So that would give us 0.999 over 0.999 minus 1. Now remember, the limit is just what we are approaching, so we don't have to actually plug in 1, because if we plugged in 1, we'd get that undefined again. So if we work this out, we're going to get 0.999 over negative 0.001, which, when we simplify, is going to give us negative 999. Now, something to note when we are dealing with fractions and division, if we have a very large number that we're going to go ahead and call infinity, and we divide it by any number, it doesn't matter, just a constant, our answer is going to be infinity. If we have a number that's divided by a infinity, we're going to end up going to 0. If you are dividing by a very, very small number, like we are in this problem, so a number over a small number, and by small number I mean, you know, like 0.000000001 or whatever, we're going to be going to positive or negative infinity based on the sign of that small number. So if we look at what we're dealing with now, we have a number, 0.999, divided by a really small number, negative 0.001, and it gave me negative 999. If we were to get closer to 1 on the left-hand side and say pick 0.999999999, our number in the denominator would be even smaller, negative 0.00000000001. So that would make our answer even bigger. So this is going to be going to negative infinity on the left-hand side. So that's giving me an idea that we're going to have a vertical asymptote, because my function value is approaching, my y value is approaching negative infinity from that side. If we look at it from the right-hand side, so the limit as x approaches 1 from the right of x over x minus 1. So again, we're going to take something very, very close to 1, but just to the right of it. So we'll pick 1.001. So then we'd have over 1.001 minus 1. So we get 1.001 over 0.001. And that's going to give us 1001. So if we were to make that number even closer to x, we could make this number that we're equal to even bigger. So we are going to end up going to positive infinity on that side. And again, if we think about what the graph is telling us, as we come into 1 from the right-hand side, my y value is going to infinity. So since I have a left-hand limit going to infinity, negative infinity, and a right-hand limit going to infinity, I know I have a vertical asymptote. Now, don't forget, we do have functions that look like this. And if that were the case, both the left and right-hand limits would be going to infinity, but we still have that vertical asymptote because we're going to a y value of infinity. So AP is not very likely to ask you about vertical asymptotes. They're more likely to ask you about horizontal asymptotes. So there are 3 rules that you should have picked up in pre-cal about your horizontal asymptotes. Those rules are going to still apply in calculus. And those rules are, if the degree in your numerator is equal to the degree in your denominator, your horizontal asymptote is equal to the ratio of your leading coefficients. Second one would be if your degree's numerator is greater than the degree in your denominator, then you are going to have no horizontal asymptote. And then on the third one, if the degree in your denominator is bigger than the degree in your numerator, your horizontal asymptote is going to be y equals 0. So what we need to think about with horizontal asymptotes, if we think of the graph of x over x minus 1, the graph looked like this. So as we look at our graph, we're going to see our horizontal asymptote at x equals 1. And all that means, all a horizontal asymptote means is what y value your graph approaches as your x values go to positive and negative infinity. So looking at the graph, we're talking about with the horizontal asymptote, what's going on at the extreme ends of my graph. I don't care what goes on in the middle part of the graph, just at the extreme ends, what's happening as our x values go to infinity. So to tie this into calculus, if we look at this, what y value does your graph approach? Well, that seems to me like a limit as your x values go to positive or negative infinity. So this is what you're going to be looking for horizontal asymptotes, the limit as x approaches positive or negative infinity. So if we think about the function that we're dealing with here, x over x minus 1, if we take the limit as x approaches infinity of x over x minus 1, All we have to do is look at our rules. We see that the degree in the numerator is 1, the degree in the denominator is 1. So we have to look at the leading coefficients. They're both 1. So my horizontal asymptote is 1. So we'll leave it there for this video, and we'll see you in the next one.